Do that one dance, baby.
Good day, everyone. This is Rose Vijoy de Rosario, EBS Ed Math student of KCAST. I am here to discuss to you about transportation model and finding its total cost using northwest corner cell method, least cost method, Vogel's approximation method, and then MODI. So, here's an example of transportation model. So, supposedly, here is our source, which is factory, and our destination, which is warehouse. So, this row is the demand, and this column will be the supply. This supply and demand should be equal, but in this case, this example is not balanced. So this is total 40, and then the demand total is 36. So for this, we should add another column to make it balance. So in this table, our problem is balanced because I added another column and to make it equal. So this is now 40, and then the demand is 40.
The first method that we are going to use is northwest corner method. So this method is a method adapted to compute the initial feasible solution of the transportation problem. The name northwest corner is given to this method because of the basic variables are selected from the extreme left corner. So let me show you how.
To begin with our first method, which is northwest corner cell method, in this table we will find the extreme left corner cell, which is this one, 5, and then we will look at its demand and supply. So we will find its least value between the demand and supply, which is 9, and then allocate it in the first extreme left corner cell. So 9, and then we will subtract this one to the demand. So this demand will become 0, as well as the supply. We will subtract 9 from this, so it will become 6, and then this column will become 0 also. The same process, but this time we will eliminate this column and focus on this side. So our extreme corner cell this time is the 6, and then we will look at the demand and the supply, which is 6 and 8, and then look at the least value, which is 6, put it here, and then subtract 6, so this will be 0, and then subtract 6, and this will become 2. Next, this will be eliminated as well because its supply is now 0. So here is our next extreme corner cell. So we have demand 2 and supply is equal to 10, and then the least value is 2, so we put it here, and then subtract 2 here. This will become 0, as well as here subtract 2, this will become 8, so this will become 0, crash, and this column will be eliminated for the meantime. So focus on this side. So now we will count our occupied cells, which is the cells that we allocated earlier. So 1, 2, 3, 4, 5, 6, 7. So we have 7 occupied cells. So this one, m plus n minus 1. M is the source, which is 1, 2, 3. 3. And then we add the n, which is the destination. 1, 2, 3, 4, 5. 5 minus 1, it is equal to 7. So we will write now our total cost. In order to get our total cost, we will look at our occupied cells and then multiply its value and then add it to another cell. The total of our total cost is 201. This is now the total of our northwest corner cell method.
The least cost method is another method used to obtain the initial feasible solution for the transportation problem. Here, the allocation begins with a cell which has the minimum cost. The lower cost cell are chosen over the higher cost cell with the objective to have the least cost of the transportation.
So let's try another method, which is the least cost method. So to start with this, let's find the smallest value among all the number here in the table except for this supply and demand. So as we can see, we have the value of 0. So we will just choose among the 3. So I'll choose this one. So we will allocate this with the demand 4 and the supply is 15. So the least among the two is 4. So we will allocate it here and then subtract 4 from 4. So it will become 0, and then 4 to 15 will become 11. So this will become 0 also. So next is the next least value is 2. So we will allocate this. We'll look at the supply and the demand. So the least is 8. So we'll subtract 8 from 8. So this will become 0. And then this will become 7. Since it is 0, this will be crushed out. So the next least value among these values is 3. So we will find the supply and the demand, which is 7 and 9, and the least is 7. We'll put the 7 here, then subtract 0, then this will become 2. So this will become 0 also. And then next is 5. Then the same, then so it becomes 0 and then 0. So that's all. And then we will find the occupied cells. So let's count 1, 2, 3, 4, 5, 6, 7. We also have 7 occupied cells. And then this one, 1, 2, 3 plus 1, 2, 3, 4, 5 minus 1 is equals to 7. Then the total cost, this one, this will total 192. This is the total cost of our least cost method.
Vogel's approximation method or penalty method. This method is preferred over the northwest corner method and the least cost method because the initial basic feasible solution obtained by this method is either optimal solution or very nearer to the optimal solution.
We'll find our total cost using Vogel's approximation method. So in this method, we will find the two least method in each column and each row and then subtract to each other. So in this first column, we have 5 and 3, and then we will subtract these 2, so the answer will be 2. And then the next column is 6 and 4, so this will become 2 also. And then the next is 7 and 4, so we'll subtract these 2, so this will become 3. Next is 5 and 2, so this will become 3, and then 0. So for the rows, first row we have 0 and 5, so we will subtract it. This will become 5. Next is 6 and 0, so the answer will be 6. And then 2 and 0, this will become 2. So we will find the greatest value among these values here outside the table. So the greatest value is 6. So we will find here the least value so that we will allocate. So here is 0. So we'll find the demand and the supply. So 4 is the least. Then we will put the 4 here, and this will become 0, and then 6. This will be eliminated. So next, we will have the same process. We'll subtract these two least value here. So 2 again 2, then 3, then 3 as well. So since we have no value here, we will just leave it blank. So for the row here, the least value here is 5 and 5. So we will subtract this. This will become 0. And then here we have 6 and 9, 3. Then here we have 2 and 3, and 1. So we will find the greatest value. So we have 3 3s. So 1, 2, 3. So I will choose this one. And then we will find the least value here. So 6. So we have 8 and 6 for demand and supply. So we will allocate 6 here, and then subtract 6 from 8 and subtract 6. This will become 0, and this will be eliminated. So next, same process. We still have 5 and 3, so 2, 4 and 6, still 2, and then 7 and 4, 3, and then 5 and 2, 3 also, and then blank. So here we have still 5 and 5. to 0, and then we have no values here, so we'll leave it blank. And then here is still 2 and 3, so still 1. We'll find the greatest value, so we have 2 3s, so we'll choose this one. So after a long process, we will now count the occupied cells. So 1, 2, 3, 4, 5, 6, 7. 7. Then this one, 3 plus 5 minus 1 plus 7. So the total cost. We will look at the occupied cells, then multiply and add it. So this will total 173. So 173 is the total cost of our Vogel's approximation method.
Go.
So our MODI method, we're going to use the table from our Vogel's approximation method since it has the least total cost among the other methods. So here it is. So we will get the used roots. So for the used roots, we will look at the occupied cells, which is U1 and V1, U1 and V2, U2 and V4, U2 and V5, U3 and V2, U3 and V3, U3 and V4. So for used roots, we will substitute the value from this table to the formula. So we'll let U1 is equal to 0. So U1 plus V1 is equal to 5 since U1 plus V1 is 5. So we will find the value of V1. So we will use a little bit of algebra to find the V1. So V1 plus U1 is equal to 5. Then our U1 is 0. So we subtract it, then we will get 5. Same process here.
Go.
For our last occupied cell, which is U3 and V4, here, so it is equal to 2. Since V4 is equal to 2 minus negative 2, which is the U3, is equal to negative 4. So after our used roots, we will find the unused roots, which is the unoccupied cells. So here is the formula. U1 V3 is 7. U1 V3 is equal to 7. So 0 is our U1, and then V3, the value of our V3 is 6. So 0 plus 6. 7 minus 0 plus 6 is equal to 1. Same here, u1 plus u1 and v4. So u1 and v4 is 5. And then value of our u1 and the value of our v4 is 4. Is equal to positive 4. So since there are no negatives in these roots, therefore there is no possibility to reduce the total minimum transportation cost, which is 173, which is the total from our Vogel's approximation method. That's all for our transportation model. I hope you learned something. Thank you.